I'll try to keep it interesting, exciting, talking about a lot of legacy stuff and how we are migrating towards the new things that you have been hearing since morning. So you heard I'm head of product management, director of product management for cloud networking at Google Cloud. And I'll be taking you through a journey of an enterprise IT who has built applications over years, and how are they migrating, and what are the methods and the tools that we offer and there exist in the open source world, and connecting some of the dots across the presentations that you have heard since morning. So established enterprises that we keep talking to. I talked to a lot of enterprises in this job and my previous job. I was vice president for cloud compute at one of the largest retail in the country. So having been there and talking to all these enterprise ITs, you see that they have a lot of legacy applications. We all are aware that they have legacy applications. Some of them have tried to do the transformation, migration. That has resulted into a lot more applications and a lot more styles of developments. So you see that there will be some hosted applications, third-party hosted applications. Some have tried virtual private cloud, so they have their own versions of private cloud. Some applications are sitting in cloud. Does that mean that the transformation has happened? Does that mean that the application scale just because you're in different places? That's not the reality. That's not how it works. Because there are still third-party lock-ins. There are still threats of technologies because all that work happened incrementally as the time demanded. There are still lots of those contracts sitting with third-party vendors because of different reasons, legals, contracts, or whatever reasons they had. So what are the biggest challenges these companies have? Why they are not able to migrate or do some kind of greenfield work in order to come out of all these challenges they're running? Twofold. So one is that they built the applications in a way where the application or the business logic had infrastructure knowledge tied into it. So very tight kind of integration with the infrastructure. The second reason has been because they were monolithic applications. In many cases, even the SaaS application that they had, they turned out to be monolithic too. So these two problems that exist in the existing world of enterprise ITs have caused the delays in migrating over to cloud or being able to accelerate or have the business agility that the enterprises want. So these enterprises, they tell us that I do want to go hybrid. And there are a lot of reports from Gartner IDC which says that by end of this year, almost 80% of the enterprises around the world, they're already thinking hybrid or they have already made a migration. So which means that most of those enterprises we are talking to, they already are in that category of what we talked about in the previous slide. So they do want hybrid. They do want to come out of these vendor lock-ins. They do want all the modernization of applications because they want business agility. They want developer productivity. So, but they want to do that by minimizing the downtime that comes with this transformation. They want to continue to use the same tools and APIs. It goes back to the developer productivity. They need a design for the applications, no more monolithic, because that has caused them a lot of pains. So that design needs to be, we heard microservices, and it needs to be something that they can manage across business lines. They don't want to be choosing different ways of deploying applications across different business lines that they have. So same set of tools, reducing the technical debt, reducing the time to migrate, and then keeping the downtime as low as possible. So those are the very, very simple and small set of goals that enterprises have put forward for us and people like yourself in the room, so to help them through this migration. So how are they going to do that? There are certain options. And a lot of you might have already heard different kinds of Rs like refactor, redesign, reapplications. You can, and in a simple language, you can tell there are four categories we see. Lift and shift for traditional applications which cannot be migrated or transformed for whatever reasons. So then you can just take this application, put it in bare metal, or you just leave it on-prem. So that's one category. Second category would be that you start to transform it because there is no other way. There is some data dependencies, there are some data regulations, or some compliance that is forcing you to go and make the transformation happen. And then greenfield. Businesses keep acquiring new businesses. They're trying to get into newer areas for a lot of business pressures. So for all those greenfield, we would see the transformation towards the cloud or just writing a lot more microservices in those areas versus something which is already sitting in the first two categories. And all of those three result into a hybrid deployment. So then hybrid deployments require some sort of API, some sort of API gateway, a consistent and a unified transactionally consistent experience across different locations and across different deployments of your applications. So let's take an example of how these two blockers that we talked about on the first slide how is it kind of blocking the experience of moving fast? How is it inhibiting the progress that the speed at which the enterprises want to kind of move? So I call it legacy development, although there are a lot of kind of newer elements that you will hear in this example. So this is an example of the same enterprise IT who has certain legacy applications, has some SaaS applications, done some migration. So the enterprise IT, the head of the company, head of this infrastructure, the vice president of infrastructure, that builds a team and asks this team to build a mobile-first experience for existing applications and then give it to its end users. They put really smart engineers. They all work together, build a mobile backend, build a mobile front-end experience, and here comes the time to launch the applications. So it's mobile. The traffic is surging. The peak hits, and what happens? It's taking more than seconds, and then the experience is going worse. Application is crashing in the backend, and why is it happening? Why the latency is so high? Why it is crashing? Because somewhere they ended up using their legacy infrastructure. They ended up connecting it to the databases the way they were accessed, the storage the way it was deployed. So the backend infrastructure was still same, and the application was accessing that infrastructure in a way that was tightly integrated with the applications. And now the root cause happens, and there is the team looks at why the spike happens and how could they kind of support that traffic spike if it happens again. So in a traditional mind, you're like, oh wow, it is traffic burst, and we have seen that the traffic will grow at this pace. So maybe we should just use cloud because cloud is used for busting. Okay. Put more set of engineers. And then these engineers are told to build application for two clouds because you want primary and you want a backup cloud. The transformation at the backend has still not happened. It's still the same infrastructure. It's still the same way of accessing your data, storage, compute, network. So the team now builds one set of applications for one cloud, again builds it the same way, connects with the infrastructure, dependent on the compute network, and storage of one cloud, and the similar things for the other cloud. So now what has happened? Now you have built additional, even though you're using your modern way of infrastructure, which is through cloud, you're using it for bursting, but what's happening is you have now created 3 dependencies on your infrastructure. So unless you come out of that infrastructure dependency mode, where your application logic is abstracted out of the infrastructure all the way from compute, network, security services, security and infrastructure, compute, storage, databases, all of it, you will continue to add to your existing legacy infrastructure, and you will continue to delay your progress and would not be as agile as you expected to be, even though you make a migration to the cloud. So what should the framework look like? So this is one of the recommended frameworks. So for meeting the business agility and the developer productivity goals that you would. So it really depends on, it's a framework. And then you can see that it's just a Lego framework. You can choose a block based on where in your journey or migration of your application you are. So let's start from the bottom, and we'll go kind of, go up in the stack. So we start from, you have to start from how you define or how do you package your application, the image that you build. So you start from there, and in that space, at least as an industry, we all have agreed, and that containers are the way to kind of define or package an application in a way that is platform independent. So, so that's where you start. You use containers. You package your application in a format which is platform independent. Then you go up. So you define your image. You know how to package it, which is platform independent. The next step would be that how do you orchestrate it? How do you deploy it? So that's where Kubernetes comes in. So then you use this image, deploy it across different platforms, again in a platform independent way. Then you go further up in the stack. So how do you life cycle? How do you manage the life cycle of this application that you're just deploying? Version management, upgrades, config, rollout, all of that. So then you need some kind of CI/CD environment. So there you can use something like Spinnaker. And then you go at the top. So you have done abstracted from the infrastructure your definition of packages and application. Then you deployed that in a large infrastructure across on-prem, hybrid, multi-cloud. Then you know how to manage the life cycle of your applications through something like CI/CD tools like Spinnaker. And then you go to the top, and then now you're talking about how this application, how do you put services onto it, which you have described using, let's say, Kubernetes. How do you discover that, and how do you securely communicate? So what is a secure communication model or protocol or framework for services that sit on this infrastructure? So there are each of these blocks, as you see in this framework, they're abstracted blocks. And as I said, that this is just a framework, depends on where in the journey you are in the migration or enterprises are. You can choose one or replace it by another one because they're all abstracted and independent of each other. So container-based methods offer a flexible approach. I talked about it. The goal is that we started with two goals. So we want applications to be written independent of the infrastructure, compute, storage, networking, all of it. And then we want applications to be not monolithic. We want applications to be distributed. So containers, we have agreed those are the model, and then we use them inside Google as well, to define our packages and our applications. So what's next? So now running applications with Kubernetes. So what is Kubernetes? It's an open, portable framework which allows developers to build applications and expose the service interfaces through APIs such that you can write these applications that are portable, and you can change those applications on the fly and deploy them very fast across different infrastructures. Again, the key is that you keep building them portable, immutable, all those words. So remember that. So Kubernetes comes and helps with that. So create an abstraction layer, or say portable abstraction layer, so that you can deploy your workloads, change your workloads, and migrate your workloads across different environments. It's a declarative way. So what are developers looking for? As a developer, I would like to describe my workload. I want to be able to define the intent or intended state for my workload. And without really learning about what is the VPC like, what is the network like, what is the firewall rule, so without really worrying about all the networking constructs, I want to be able to just define what my workload will do and let the orchestration or the automation deploy and understand the infrastructure, discover where is the best place for it to be placed. So Kubernetes offers you that declarative way of describing your workloads. And since it is declarative, you can again use it you can port it across any kind of infrastructure, whether it is across different clouds, on-prem. So looking at this picture, what else is required other than just exposing that declaration for your workload? Abstraction is very important. Like you see that in the same Kubernetes API, you're able to expose, which is like consistent API. So declarative model through consistent API for different infrastructures, and how easy it becomes for you to use and deploy your workloads. As you can see in this, on one hand, with the same API, you're going over to GCP, so you don't have to be worried about now the same set of engineers who built an application for on-prem. They can be doing the same kind of application development even in cloud. They don't have to worry about how GCP networking works, or when it comes to on-prem, they don't really have to worry about how the on-prem networking is on-prem networking is designed and deployed. So it makes it very easy. So you defined it, you expose it through API, And then you put some ingress, or let's say load balancer. You heard in the previous talks that NGINX is also integrated, and it is being widely deployed and used in a lot of in Kubernetes deployments. So you use an ingress controller, or which acts as a load balancer. We also have the similar things in GKE, like Google-supported Kubernetes engines. It load balances your traffic, and it does a lot more than, depending on what the capabilities of your ingress controller is, you can get a lot more out of it. You can get WAF capability, DDoS capability, a lot of capabilities that are tied into that. So it just makes you do not have to worry about your ingress side. You can get all the advantages of security and load balancing and all of it there. You're abstracted from how the infrastructure is. You just have to focus on how you converting your business logic into the application logic. So containers at Google, if you haven't heard of it, if you have heard of Kubernetes but have not heard that, it really came out of our own infrastructure management container or cluster management system called Borg. So all our applications, like the applications that you hear, like Gmail and YouTube and Search and many others, all our infrastructure applications, they're containerized and they run in the containerized infrastructure. So we deploy like 4 billion plus. I think this number has gone up high, like it goes high it just keeps going up and up every week. So 4 billion containers every week. We manage it at that scale. And then we also use that experience. Like, this is our own infrastructure, but what we do is that we keep converting that experience of managing those containers at scale over to GKE, which is our container, which is our Kubernetes managed offering. And at the same time, we do continue to kind of add back to the community, because we do believe that that scale is required to make the hybrid or the true cloud happen. So we talked about, we went from the packaging, looked at the orchestration across different infrastructures using Kubernetes, and then now the application lifecycle management. So as we talked about, Spinnaker is what we are going to talk about. How we do CI/CD on Google Cloud. So we take an image, which sits in the source repository. Then you convert that business logic into your source code. And then you take that source code, then you go take it through your cloud build, build your application, you do a testing, and then you store it. You use container registry. That's our internal registry for containers, which is backed by cloud storage. So you save that information there, and eventually you use Spinnaker as a continuous deployment tool. So what do you really need to, if you are an enterprise, small enterprise, who is just trying containers and who's just trying building applications, do you really need to use these tools? No, these are our tools, and then these could be deployed and replaced by others. As you already see, Jenkins is there. So look at the bottom, instead of container registry, you could use Docker Hub. So you could replace any of those components, again, depending on where in the cycle you are, what you're comfortable with. But the idea is that you need to be thinking about how do you do the application lifecycle management. So why do we choose Spinnaker? Spinnaker is another open source tool. So it does the application deployment and application management. The reason we use it, because it's very it gives you a lot of application visibility. It gives you an application-centric view, especially if you think about container-based deployment. So you can see all the way to where is your cluster running, how many pods are in there, the health status for each of the pods, and then how many deployments are running, what namespaces. So it gives you a lot of visibility into your, what state your application is going through when going through the pipeline that Spinnaker offers. So pipeline. So everything that Spinnaker does is through a pipeline. So what is a pipeline? It's kind of a set of stages that you use in order to go from version 1 to version 2 of your applications. So if you want to take an application from staging, like what we have here on the screen, so you can pick your application which you have already staged, take it through multiple stages. In this, we are trying to do canary rollout and then use the canary canary updates or status in order to get to upgrade the application to the production. So it helps you build those stages. And with this application detail view of how that application, that staging, or sorry, that staging is going, what is the update on the staging, or what is the status of the staging, you can get very detailed level view of that with Spinnaker. So there are multiple deployment strategies that are supported. So you can do your blue, green, red, black, like whatever you call it. Some people call it red, black, some call it blue, green. Strategy, what does blue, green mean? Like very quick, so that's the more traditional model of migrating or introducing your newer versions and applications into your production. So what you do is that you set up, like, let's say in this picture, you have 8 set of resources or 8 pods, let's say, comprising your application. So you will bring in that full application, then you will do your newer version of the application, and then you would use a load balancer to go from version 1 to version 2. So you would basically just point the load balancer to the newer version. So there are other, and the previous speaker talked about Canary, and that's what we use in Google. So we support, Spinnaker also supports that. What is very quick Canary does, you kind of pick a specific traffic load, and you direct it to a specific workload, specific traffic, targeted for certain users. And you do that in production. So you run the production, certain part of the production traffic through certain parts of the workload. And then once that is ready, and then you compare it with a baseline that you have created for that traffic, and then you kind of give it a score. So once you think that the score is kind of acceptable score for that amount of traffic, that amount kind of matrix, and then you promote your application to the production. So Spinnaker supports all these versions, and we continue to add a lot more information to Spinnaker as well, and works for us. There are other things that, very interactive. You can do triggers-based deployments, and you can do manual. It gives you option for manual judgment, manual rollout, as well as automated rollouts. So what's next? So we talked about packaging. Then we talked about how at scale you can deploy your containers, and you can manage those applications. Then we talked about how do you manage the lifecycle of your applications through tools like Spinnaker, and you can always use other tools like, as we refer to, like in Jenkins and others. So now, once it is done, you have multiple versions of APIs, you have multiple versions of applications running on different infrastructures. That's the kind of beauty. Every time we abstract things out, they also introduce complexity. So the biggest challenge that comes with microservices is that how do you visualize that? How do you make sure that who is talking to who? What is the policy? How do you define that who can talk to whom? And once you have defined like who can talk to whom, can you troubleshoot if they're not able to talk? Do you have enough log information, monitoring information to be able to kind of visualize the billions of, for example, in our case, billions of containers that we are talking about? How do you make that communication secure? How do you identify you're talking to secure endpoints? And how do you make sure that the communication is encrypted, secured, authorized, authenticated? So that's a big challenge to address. And the two of the frameworks or protocols that we use in order to manage these challenge. So you have heard both of them in the previous talks, Istio and gRPC. So we connect and secure applications or microservices through these two tools and applications or frameworks. So again, just like Borg gave rise to Kubernetes, gRPC came from our internal microservices communication protocol called Stubby. And so we do 4 billion containers a week and do almost billions of RPCs per second. So you can imagine, right? So there are like so many applications, so much infrastructure. So this is the scale at which we had been running Stubby when we open sourced it to be a protocol called gRPC. So these are some learnings, and I saw some of it in the previous talk as well. So what did we learn from Stubby? Like, microservices, service-to-service communication, any service talking to any service. So what did we learn from that experience that we brought over to gRPC? So we learned that there should be strict contract between services. We heard Isa talking about that as well. So that's really important when you are in this gigantic world of microservices. The contracts have to be very strict. you need a common language to talk, and then as well as common language for encoding the objects that you're exchanging between your application. And it will be great if you can. It's a human-readable language that you're exchanging for encoding. And adding some additional constructs like, say, deadlines and then cancellation, flow controls. Flow control have been built into most of the communication languages, but deadlines are like, when in this massive world of like services talking to each other, you need to set up some deadlines on when a particular communication is going to end, forcing that communication to be canceled. And rate limiting your messages between your applications. Otherwise, they can just cause a lot of latency, a lot of like your infrastructure usage for messaging that you would not like your infrastructure to be used for. So being very cautious about all of that. So in summary, like based on these learnings, what else did we learn is that it's really, really in this, when you're talking about microservices talking at that scale, it's important that you have a common point of monitoring, logging, tracing, service discovery, all of it. Otherwise, your life is just going to be very difficult troubleshooting and keeping your infrastructure optimized and efficient. And most of the advantages that come from abstraction and running at scale or managing at scale, may not help you so much. And then you may end up just increasing the complexity. So what is gRPC? gRPC is a very optimized client-server protocol. It offers you streaming. It's a streaming protocol too. So it's a client-server as well as a streaming protocol. It is used in service meshes. Many customers and partners of ours use, and you saw that. I guess NGINX support it as well. It speaks your language. We have been hearing about support for multiple languages since morning. So it does like 10+, like C, C++, Java. So you choose your language. You build your client library in the language that is most familiar to you and that you think works best for your environment. It runs everywhere. So mobile had done a transformational impact, at least for us with Chrome and Android and all of it. So we needed a development framework to support the scale of the mobile development that we have. It had to be a very optimized protocol. It needed to be something which is not just creating a lot of connections that the scale of the Android or scale of the Chrome could not support. So we have support for mobile devices. It runs everywhere for us, whether it is in cloud, data center, and devices. So this is the protocol for us that we use in order to scale for services across different endpoints. So some of the advantages, it's HTTP-based, offers multiplexing, offers streaming, does authentication and security. You can use like any of the names that you see here for monitoring, tracing, integrates with Prometheus, all of that. So you will see some of these themes common across in the next topic that we talk about, which is around service mesh, and then the framework that is based on service mesh. So what is a service mesh? You have heard some definition before. So in a service mesh, again, the theme is abstraction here. So we are talking about how do we transparently automate application network functions. So application, as we started, the reason that enterprises are not able to migrate fast because they integrated the infrastructure logic, including networking, into their applications. So now we are trying to abstract multiple layers. So taking the business logic out of the applications, taking the business logic separate from the network, and then doing that seamlessly, that's what service mesh is. So that's what it should offer. And then you being able to monitor and secure, connect, all of that still in a seamless way so that the developer is not aware of it. So they can continue to focus on writing the business logic. So being able to automate your application network functions while you're able to keep your business logic out and still continue to abstract away the complexities of the network functions. So that's what really a service mesh is supposed to do. So it's a quote from one of our internal users. So it's interesting. We have used it across all our presentations. So and the person, we couldn't get the name of the person, so it's really anonymous early adopter. So yeah, we all got fired up about Kubernetes and microservices, and then, wow, what's going? So, but we needed Istio to tell us and view our entire system and found the trouble spots. So it's like, and we all know that when you talk about microservices, one of the biggest challenges a few years ago when containers came in was that how would you do the networking? How would you do the security? I don't know what's happening to my applications. Where are they sitting? So it's really, really important that you just connect all those dots, and then you have a control, and then you can manage and control the traffic, manage your applications, and then continue to visualize. And that's when you will be able to, if I go and take it a step ahead, which is if you want to build any kind of analytics, if you want to do any kind of business agility and continue to focus on building business, you really need visibility. You really need logging. You need monitoring. You need to put all of that information together to make really some sense out of it for the business. And that's what Istio does. It's a service mesh, which means it has separated out the application logic from the networking so that you focus more on application. It's an open framework. It helps you connect. Yes, there were a lot of methods to connect before too, routing, switching. They all had been doing it. But it can help you connect at an application level. That's the difference. And it allows you to secure, manage, and monitor your services. So, and how it is doing that? We're just kind of, going a little deeper into that. So when we talk about connectivity, we are talking about intelligent routing. We are talking about HTTP level routing, application level routing. If it was L3 routing, you wouldn't really need a different model to do it. We could have just used a lot of protocols to manage that. And the application routing, the reasons that you want to do that is you want to be able to do the application management, like using canaries and A/B testing, and then other things that you can offer in the virtual and the cloud-like environment. So you want the application services to stay resilient. So you want to be able to see when the timeouts are happening. You want to be able to check your retries, what your health checks are doing. And very important, when your applications are not working properly, then you want to be focusing on where your circuit breakers are, being able to control for how long would you keep your circuit open or not open, so that you have full control even in the failure scenario of your application. So security and policy, do you want your service communication to be encrypted, non-encrypted, use mutual TLS, and then being able to define the policy all the way for your organization at each department level, organization level, all of it. Have the control for that. As an organization, you do want the control on your policies. You do want control on what kind of encryption or communication happen. And very important, as I talked about before, really, really important in microservices were that you keep a tab or control of your compute and network resources. Let's say just two applications become so chatty that your premium enterprise applications in cloud becomes impacted. That will be a very difficult situation from many angles, compliance angles as well as risk angles. So you do want to make sure that you're putting rate limiting on messaging or the information that is being exchanged between two applications. Let's say requests per second or queries per second. So very important to do rate limiting. And of course, telemetry. You want to be looking at logs. You want to be looking at distributed tracing. There are a lot of open source components that you can use to do the monitoring, like Prometheus, as well as you can use Zepkin to do your distributed tracing. So all of that kind of works in the Istio framework. So how Istio works, it's an abstracted service control. It introduces a control plane, services control plane. So and exposes those interfaces through an API, a consistent set of APIs. So there are three parts to it. So one is pilot, which helps you configure and push service communication policies that helps you manage your traffic. So that is a traffic management component of it. And then you have a piece called proxy. And then NGINX works very well in a proxy mode too. So you use it as a sidecar proxy, and we'll look at one example of what that means. So what it really does is that proxy is your intelligent piece there. It does the interception. It intercepts your communication, and it helps you apply policies. It also collects the information which is required for your monitoring and sends it back to the second component, which is called Mixer. So Mixer helps you with policy enforcement, quota enforcement, and it also helps you do the telemetry for this control plane for the services that it is managing. Then the third component is Citadel. It used to be called Istio Auth, and it does service-to-service authorization using mutual TLS. It has built-in identity management system and the credential management system. So let's just take a look at how this proxy works here. So what happens is if, let's say in this front end is an application which is talking to payment. So if a request comes from front end, so the request is intercepted by proxy. It looks at this request. It makes sure that the configuration that Pilot has, Pilot module has pushed onto it. It looks at that configuration. It checks all the conditions, and then it also logs that information and sends the messages to the application called front end. And then front end does its work, and then it just seamlessly sends this information over to another application called payment. And then even on that side, again, the proxy intercepts it, does the intelligent routing, does the intelligent kind of all the work that it needs to do, whether it's traffic management or traffic control. And then payment responds back, and it goes to the next application. So please note that in this example, this is very different from, let's say, if you were using gRPC, or if you were any client library-based model. You're talking about a sidecar proxy, which is kind of running as a process just next to the application. But they're really working together. But the application does not know that what the proxy is doing, which means a clear separation of your business logic from how the network is working. So you can continue to build intelligence of infrastructure into your proxies, and then you continue to developers can continue to build in the logic into the applications. So work very cleanly and can scale very well. So this is an application, example application where front end is a front-end application where user comes in, it talks to another service called auth, which talks to user. Then front end talks to pictures to kind of grab the pictures from a repository. And then front end also, after picking up the picture, it goes to backend payment. And then payment service then goes to an external identity. So how would it look like in the world of Istio? So as I said, that you will put a proxy with each of your services, and then but the application or the service, let's say front end, is not aware. From a design perspective, as a developer, you are aware that, or administrator, you are aware that these proxies are sitting there. But as a developer, you are not aware, and you do not need to be aware that what the proxy is doing, how it is routing, how it is networking. So you put it there, and then this is how it will become. The application or the service that we talked about with 4 modules, it will have proxy in each of those services and components. And this is how it will scale. So think of it as a kind of internal ring. Like if you can imagine, there's all these proxies, they're in this inner circle of talking like a network and security policies and all of it. And then the applications are sitting outside. So they are managed independently of this network infrastructure. So internal circle could continue to scale, while your external one could continue to scale. And you use, and then how do you do testing, or how do you manage the deployment of such applications? Again, pretty cool, because we do have the traffic management capabilities. You can use your, say, canary-like model at the application layer. If it was an L3-like proxy, or if it was an L3-like routing or traffic management behavior, you would still be sending infrastructure-dependent traffic, which is send 30% traffic to one deployment, send 70% to another deployment. But the beauty of using this framework is that you can use HTTP-based routing, and you can really say that, hey, I have a traffic coming from iPhone users, send them to this deployment, and I have a traffic coming from, let's say, Android users, send them to that deployment, because you do have application-level visibility, not the infra-level visibility. So that's the kind of beauty of using such frameworks like Istio, because it is really doing work at the application level or the service level, and you just kind of think in terms of service. You can really think real, how you think in abstract or in real life, like users instead of IP addresses, users instead of profiles, So that's the power of using something like this. So we talked about traffic management or traffic routing at the application layer, but the very important, and we talked about monitoring and how you log it and how do you save it, save that information so that you can, the business can make some sense out of it and maybe put some analytics on top. So, but when you're sending a request, let's say from front end to payment, how do you know that you're sending it to the right party? What is the, who helps you kind of build that identity? So Citadel helps there. So it's an identity as well as a certificate management system. So the front-end service talking to payments, so they will exchange certificates, and that's how they would know. It can also assign identities to these services and applications, and then they can also be used like, to manage your backends, like backend services once identities have been identified. So you can map your identity of your backends all the way to the identity management system on-prem. So that's how you think about it, like how these two words are connected. So you went from, you started from packaging, you went to Kubernetes level, kind of very high-end deployment at scale. Then we talk about the lifecycle management of applications through Spinnaker or some other tools that you have. And then you use Istio and gRPC-like protocols, and which make this communication secure and offers you traffic management capabilities, logging monitoring capabilities, and offers you identity-based management systems or authentications, so to make that entire service management or the service communication happen. And every time you do that, you're using consistent APIs. That means you're able to talk on-prem or to other cloud. Every time you do that, you're creating these identities which you can build into your identity systems, which can be cloud-based identities or the identity system that you're used to building on-prem. So even though it looks like the newer way of thinking, but every single step that has been added here maps onto how enterprises are used to thinking. And it results into the highest kind of agility for the businesses, because it continues to focus on how you keep the business logic out and how do you keep business logic abstracted away from rest of the infrastructures. But at the same time, because the people who are building the business logic, they're all the developers like us, and we need to be able to support the infrastructure abstraction, but at the same time giving them tools that they can use to continue to focus on the development side of it. So as I said, like I started with these. This is the framework that we use, but they are just Legos. You can choose to use 1 layer, 2 layers, or what meets your goals for your applications. So these are certain links. Some of the Google links that some of the GCP Next talks. Some are like our strategies on how do we support like hybrid. And what are different strategies you can go to enterprises and talk to them about. So with that, this was the last slide. Thank you.
Wow. So thank you so much. I think that was great to get some insight into the stack that you guys are using, and I love the advice that you sort of adopt which layers make sense for you. I just have a few questions, and then we'll let you go. I think you're off to Asia next. I think you were in Atlanta for all of 12 hours. So I get that you adopted at different levels, but can you help the audience think about what are some of the thresholds that make sense to go all the way up to, say, a service mesh level of capability? Is it in the size of your environment? Is it in the number of services you run? What are some of the advice that you could give?
So that's a great question, and it does not. Although we use it for the scale, this has helped us at the scale of the Google, the infrastructure that we run globally. But it doesn't need to be at that scale. You can really start from one pod or one cluster, and just use it from there. You use containers in that pod, and then you build your put your ingress controller, like could use NGINX, and then you can use service mesh on top of it. You don't really need the scale to kind of get to that, any of the framework things that I talked about.
OK, excellent. And then my next couple of questions are, I think, we always hear, oh, we aspire to operate at the scale of Google, or it'd be great to get a little insight. And so I'd be remiss if I didn't ask you a few questions while we had you on stage. So what's next for you? I think you've got your framework, and you've made it clear kind of what you're focusing on now. But if you're sort of out there on the front end of all this, What are you focused on? What's 12 months out for you?
So a lot of these things we talk about in terms of containers and the infrastructure, so they are a combination of enterprise workloads that are running on Google, as well as our existing applications, like I mentioned. So how do we have mastered, I would say, and I'm very proud of this. Even saying that I joined only, I'm at Google Cloud only for 9 months, but I am really, really surprised, pleasantly surprised at how could we manage such a massive scale of services. And all that I talked about, that's real. So when I look at all of that which has happened, like through Borg to Kubernetes, and then to, say, Stubby to gRPC, and many other things that Google has done. So now doing the similar scale in cloud, and that requires a different level of monitoring, visualization, because you're talking about enterprises where you sign some contracts with them, like how the data will be offered, how it will be managed, secured. So I would say security, of course, that's there every single place. But how do we offer the visualization, monitoring, and make it self-serve to our enterprises? So self-serving information across all the monitoring and end-to-end monitoring, visibility, analytics, all of that in the space of the cloud, that's what we are focusing on. And that's really keeping me kind of thinking. And then, how do you offer that at the Google scale? We will continue to, work in that direction for a couple of months or years.
Excellent. And then last question, just building on that. So what keeps you awake at night? What keeps the person who runs Google Network awake at night?
Yeah, I mean, there are a lot of people who are keeping it secure. So we have SRE teams. We have a lot of people who just 24/7 just run it. But I said, how do we continue to kind of onboard new enterprise customers? And then the promise that we give to the whole world, like when it comes to Kubernetes and service discoveries and STOs. And so how do we continue to play very well into the open source space, but at the same time give that confidence to our enterprises that we can, just like we manage Google at that scale and keep it secure, we can also give that manageability options, or we can give the same kind of manageability experience to our enterprise customers so that they feel like they are also operating like Google. So if we can continue to do that, and that will be, we are already doing it, but we are still we're not #1 cloud provider. So we need to be there, and then in order to do that, we need to bring in a lot more enterprises, a lot more large IT workloads to us, and that's what keeps me awake and enthusiastic and energetic.
Great. Well, thank you so much for joining us in Atlanta, and a big round of applause for Lakshmi.
Thank you.